practicing 4 through 7. So I'll give you about 5 or so minutes to try to get as far as you can. If you've already practiced last night, then we'll check the answers in a little bit for it. Alright, so let me check your answers, and then I have something for you to do, that way you can help me. So we're going to save time later.
SO4, that's 1.
Yeah, SO4, what ion is that?
That is sulfur.
Good job. Alright, so that one is correct.
Up there.
Good job. Alright, did you write down for application number 2 in the book? Did you write down all of the correct answers? For application number 2 in the book. We went over them in class, did you copy them down? Okay, if you didn't, I actually need you to rework them, so the way you can get the correct answers to put on the board, because we're going to need those to talk about the different types of reactions. Yeah, application number 2. So if you didn't write down the correct answers, that's okay, just try to resolve them. I believe it's 52, let me double check. Yeah,
It's already
52.
balanced. Number 4.
Good job, it is. Figure it out. Alright, so number 4 from Jamie and Quentin, if you're looking at that one is actually already balanced all the way. So if you want to write a 1 in each spot, you can, but it's understood that, hey, this one's already balanced, they're already done. Yep, application number 2, A, B, C, and D. But if you can't find it, it's okay. Just get practice rebalancing them. That'll give you something to work on.
In class?
Yeah.
I don't. Yeah.
I should know if you wrote down the answer somewhere. If you didn't, it's okay. It'll give you something to do in practice, so you're not bored.
What is AL?
That's probably letter C. Yeah, because I think we did that one yesterday. We did A and B on Tuesday, so try to go back to them. If you can't find them, it's okay. Just rework them. But it'll give you practice. That's the main thing.
I don't know. I can't really decipher what it is.
Okay. Like you can't decipher your homework, or you don't know how to.
I don't know what I wrote.
That's okay. That's fine. Yeah, so just work. It'll give you practice, which is also part of the main thing. It'll give you practice. These are just a little bit harder. That's why we did them all together. But you're doing good.
Mine number 5.
You have number 5? Alright. What do you have for number 5, Ethan?
1, 5, 5, and 1. Got the blanks.
Okay, yeah, that works for it. So you have 1 of the V2O5, 5 of the calcium sulfide, 5 of the calcium oxide, and then 1 V2S5. Alright, anyone have any, pretty sure you got the right answer. So you have any questions about that one, Ethan? Nope, that's it. Good job. It just takes practice to get these.
And looks like number 6 is already balanced too.
Yep, number 6 is also already balanced. So those all just get a 1 in front of it.
What would iron 3 oxide be?
Alright, that's a good question. So if it's iron 3 oxide. Alright, so what does the 3 tell you? It's iron 3.
There's 3 irons.
That's prefix.
It's charged to
It's charged to a 3. How much does oxygen or oxide typically take?
1, 2.
2. Alright. take two at a time, iron three, you can only do three at a
So
time.
you're gonna need two and then three.
Yep, that's it. Like I said, this is good practice, will help you get ready for your test.
I have number 7.
Alright, number 7, what have you got for that one, Ethan?
3, 1, 1, and 1.
Good job, so it's 3 of the silver bromide,
Alright, now I get this.
1 of the gallium, I believe is that one is phosphate, and then 1 of the silver phosphate, and then 1 of the GABR3.
We'll keep going. One more?
You can do one more, but then I want you to do the last 2 for homework, so that way you have something to work on to get ready, so that way it's fresh in your head for tomorrow. And you'll be able to do it on your own. It sounds like you're doing good. If you need to pause the video, JB or Quentin, because you need to slow down a little bit, that's okay.
Gaseous water would be.
It's just H2O. It's just in the gaseous state.
What do you do? So like there's iron, but there's no iron on the other side.
Alright, so it says iron 3 oxide forms from its elements. So something is combining to make iron 3 oxide. So what's combining to make iron 3 oxide?
MgOH2 and then MgO.
Are you looking at problem number 2 or problem number 1? I mean, you're looking at B or you're looking at A?
That makes sense.
Yeah, that's come on, I was like, okay, if we have iron, we shouldn't have magnesium. Alright, so what makes up iron oxide? Iron 3 oxide, technically.
FeO.
Yep, so you have iron that is combining with oxygen, but can this one exist by itself?
So
Wait,
yeah,
wait.
it can.
Can this one exist by itself?
No.
That's the problem. Alright, so that's basically what it's boiling down to. So now you have to balance them. So now
you just do two iron, and then you do a 3 in front of the O2. Put a 2 in front of the FeO3. So that makes that Fe. Put a 4 in front of the Fe. And that's balanced.
that's not okay. Copy it over there for me. I'm gonna need it in a little bit.
Copy
Ready?
for that answer.
Yeah. So copy that
Right.
answer over there because I'm gonna need it in a minute, but I need this half of the board because I gotta teach something.
Number 8.
Oh, can I shoot? Okay.
Yeah, no, you need to just drop
There's
it.
no core.
Yeah, so.
Yeah, number 8.
Alright. Paper. Alright, what have you got for number 8?
3, 2, 1, and 3.
Close. Double check it.
Three, 2, 1, 4.
Yep.
3, 2, 1, and 2.
Yep. Alright. Start working on start working on letter B then. I gotta help you with this one.
Did you start with OH first?
I would not start with OH first because you have
SO4?
yeah, I would start with SO4 first. I'm gonna run out of room. I gotta remember to write on farther to the board.
On the product side, it does not list 12 SO4s.
Say it one more time.
12. Right?
12 SO4s?
It says 4 and then there's 3 under it.
What's the 4 referring to?
That's SO4. So there's 3 actually. That's what it is.
Yes, so there's 3 SO4s.
Oh. So is it 3, 2, 3, 2? 3, 2, 3, 3?
Nope. It's okay, I'll Alright, did I copy it down correctly? Because again, dyslexic, I want to make sure that I don't accidentally mess you up by not copying it down correctly.
Problem number 2 is already balanced.
That's good.
Let me check.
I was trying to figure it out.
Because I'm doing 2 problems at once and I can't focus on that.
I was trying to figure this one out.
Yes, it is. So go ahead and copy that one on the board for me. Thank you. Alright.
Going
So-
to put it under.
Yes, please, because we're going to talk about it. Alright, alright, so Ethan, which one do you want to start with?
Oh, SO4.
Okay. Yeet. So I'm just going to put it for this so you can see it. Alright, SO4. How many do you have on the reactant side? Just starting off with. Yeah, and then how many on the product side?
1, 3.
3. So how do I fix that?
Put a 3, 4.
Good job. Alright, so SO4 is balanced. I don't have to worry about those O's right now. And then I balance those O's together. Alright, which one do you want to do next?
Guess we'll do B next.
Yeah, you probably want to do B since the hydrogen and the oxygens are kind of weird. Alright, how many B's do I have on the reactant side?
2.
We're in the reactant
one.
side? Alright, how many on the product side?
2.
Good job, how to fix it.
2. 4.
Alright, so that gives me a 2 and a 2. The boron's done. Alright. Alright, do you want to do hydrogens or do you want to do oxygens?
Might as well do hydrogens.
Alright, how many oxygens do I have over here then?
Oxygen. 1, 3. Oh, hydrogen. I thought you said oxygen.
Oh, I'm sorry.
2. 6.
6. Alright, and then how many right here?
6.
Good job. So 6 plus 6 is?
12.
Alright, how many do I have over there?
2.
Alright, how do I fix that?
6. 4.
Yep.
I'm close. I don't know. I was close.
Yeah, you did.
So
You
it's
just,
'cause
I
I
think you
just
just
started
forgot
again.
about either these or these. So everything else was right except for this one. So I knew you were close. Alright, so how many oxygens and just to double check. So we're not gonna worry about these because they're part of the ion. But how many oxygens right here?
1.
Okay, like how many total right here?
6.
6. How many on that side?
6.
Yep, so oxygens are done. Alright, so does that answer your question for? Alright, so yeah. So just don't forget if you have them split apart to make sure that you find both sets. Alright, so you'll do 8 and 9 for homework next. If you already finished it, good job. That's not all your homework, but just make sure you're going over it. Alright, we gotta teach a little bit of new material. Thank you, Chris, for being a helper. Alright, so turn in your textbook. So once you write down that answer, Chris, you can go ahead and stop. And then we'll come back and work the last one. But thank you for being a good helper. Alright, your book points out on page number 52 that there are 4 basic types of chemical reactions. There is technically a 5th one, but your book's just pointing out, okay, for right now we're just going to worry about just the 4 basic ones. One of the reasons we want to study this is because scientists can see and hopefully predict what will happen in a lab whenever they mix substances together. They want to know, will it make a new substance? Will it explode? Will it break apart? What's going to potentially happen? So that way they're not going to do something dangerous in the laboratory setting. So it helps them kind of figure out, okay, what will possibly happen? So your book points out that there are 4 basic ones. Technically, there's a 5th one with combustion, but your book's just ignoring that one for right now. So page 52. Alright, the first one is a combination reaction. If you're having a combination reaction, what does that typically mean if you have a combination of something? Alright, Ethan.
Say it again?
If you have a combination reaction, or if you think of it, if you're combining things, what's happening? What does that mean? If you are combining something, what does that mean? Like if you had to use it in a sentence.
You're changing I don't know.
Okay.
Does compound reaction mean there's more than one reaction going on at a single time?
That's a good guess, but not quite. Basically, whenever you are combining, let's say, red and blue paint, what do you get, Ethan?
Orange. Right?
You get red and blue?
Green?
Red
I don't
and
remember.
blue?
Orange?
Okay, it's been a while.
It's not orange.
Purple.
Purple.
I was about to say purple.
Or, yeah, it's red and yellow is orange. So, red and
I don't
blue.
remember all.
It's been a while. It's okay. So, that's the idea of a combination. You're having 2 elements or 2 compounds come together to get a new substance. So, make a note for that one. A reaction which 2 or more substances chemically combine to form a new substance is known as a combination or synthesis reaction. That's another name for it. The book gives you several examples for this. The first one it gives you is with carbon and oxygen. You can react to get carbon dioxide. So you have 2 substances coming together to get a brand new substance. You can also have pure sodium and you can have chloride together. They produce sodium chloride. We've already talked about this. Alright, what is sodium chloride? You can eat sodium chloride probably every single day at some form in America. Yeah, table salt. So you have first substance combined with second substance equals the third substance. I use different colored chalks whenever I teach this, so I'm gonna get out one of my other colored chalks. I don't know how well it'll show up in the video because they had a hard time last year seeing them. So in the video, say it one more time. Red didn't show up well last year, like at all. So we're gonna try this yellowy one. This one shows up better in the video, so I'll try this one.
Sure, it's closer to green than red, that's why. Like the yellow is closer to green in its colors than
Well,
red.
for this one, it shows up bright on the video, so I mean, it has a really good residue for this one. That's why I use the yellow. Red, it has a hard time, and the blues just like fade into it. So you have substance A plus substance B. Your book shows it as its substance A plus B or combined together. If you write like so, C also works as a whole new substance, but your book is trying to basically drill in that it's two substances now combined together and they act entirely different. So sodium acts entirely different from chlorine, but together, sodium chloride is not just, oh, we're going to just combine their characteristics. No, it acts entirely different. You can eat sodium chloride. You can't eat just sodium or just chlorine, you'll die. So that's why they act entirely different for it. So your book shows it as A plus B equals AB. Don't memorize it as A plus B equals AB, but memorize it as you have a first substance plus a second substance equals a third substance. Alright, so anyone have any questions about that idea? So if you see two substances combining together to get one substance, that is a combination reaction. So you can probably tell when I'm going to go off with this in a few minutes for this, but it's okay, we're not quite
Oh, is that right? Is the top one?
For what?
The top one.
Is it what?
Is it right?
Is it like, you mean like right balance?
Is it, yeah.
It should have been if you copied it.
Because Fe2, no it's not. Because then that means you have 4 F's and you only have 2 F on the right side.
Oh, you wrote them as a capital letter? I think that's why it's throwing you off. Alright, so I'm just going to erase this to make it lowercase for you. Alright, so this is Fe2. So how many total Fe's do you have over here?
Oh, okay. I see.
Yeah, that's what you're doing. So you're just psyching yourself out now for it. But yeah. Alright. So, anyone have any questions about a combination reaction? Basically, if you have two compounds coming together to make one compound, or if you have two elements or more coming together to make one compound, that's combination. Very
Is this gonna
straightforward.
be on test?
Yes. That's
Like,
kind of how
like compound, like the def, like it's gonna be like short answer.
it's going to be, I don't remember, but I think I give it to you as like, I give you the equation and then say, what type of reaction is this?
What, so it's not compound, what is it?
What do you mean not compound?
If it's not a compound reaction, what kind of reaction is it?
Oh, we're only about the 3 other types in a second. So you have combination first off. So combination, so remember it's not compounds, remember combination because they are combining together for it. Alright, the next one is decomposition. If something is decomposing, what's happening to it?
They getting got.
It's getting what?
They getting got.
It's getting got, and what's happening to it?
It's disappearing. Like,
Yeah, it's breaking apart basically. So if you find an animal on the side of the road that is decomposing, it is dead. And it is now
Nice.
falling apart and it's gross and you don't want to go mess with it. So
Yeah.
a decompose, did you say eat it?
Yep.
A decomposing, you're gonna eat a decomposing animal.
That's
you will
what you
get
think.
you will get sick. Yeah, that's part of the reason why it has to be
That's
freshly dead. If it's longer than I forget how many, it's like a couple of hours, then you're gonna have maggots and other stuff on the inside of it. And
Nice.
it's nasty. Alright, decomposition. So if you have a first substance and it breaks apart into 2 substances, this is a decomposition
That's
reaction. So I mean, this is straightforward. So decomposition, it's decomposing or breaking apart. Typically in chemistry, there's 2 ways to cause something to break apart. Once you have a substance combined together, typically it won't break apart unless you add heat or unless you add electricity to it. Then you can shock it and break it apart, or you can heat it up and break it apart. Your book gives you the example again of sodium chloride. Sodium chloride, if you use an electric current, it'll break apart into sodium and chloride that way for it. But typically, table salt will not just decompose. You have to run a current through it in order to break it apart. Now again, this is technically not balanced, but your book's just pointing out that it'll break apart for it. Okay.
So technically, you can make a bomb with table salt.
It'd take a lot of table. It'd take a lot of current.
A bomb?
It would take a lot of
Did
electricity.
you say bomb?
Well, to get chlorine
Did you
and
say bomb?
I
sodium.
said bomb.
Bomb.
I was about to say.
It would take a lot. I don't know how you would do that safely.
Like
'cause
more
you
than
would-
your house produces? More electricity than your house produces?
I have not looked up how to break apart sodium chloride.
So,
It's
and
probably a pain. Because remember, sodium chloride wants to be together, so you have to basically use a current to force it to be
You think
apart.
more than a pound of salt?
I have no idea. I've actually not looked
That's
this
a
up
lot of
at
salt.
all.
Now that's a lot of salt.
Alright, so as a side note, just as practice, this is technically not correct and not balanced. So, but if you know what you think, well,
It
looks
is balanced.
It looks balanced, but think of it. Can sodium exist by itself?
Yes.
Can chlorine exist by itself?
No.
No, chlorine always has a partner.
I eat chlorine.
So now, how do I balance this? I'm gonna shake your hand.
What I did before.
Okay, wait, 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 your hand. Raise your hand. You may do 1. Okay.
You already said the answer.
Okay. What is it?
Heated.
Okay. Well, what?
Okay.
I didn't see that.
Put a 2 in front of the NaC1, or Cl, why did I say C1? Put 2 in front of the Na.
Yep. And and apples count. So again, some of them are straightforward. So, but that's your books pointing out they do have one substance that breaks apart into two. This is decomposition. So just make a note. So decomposition is breaking apart. So if you have one substance, so where you have AB and it breaks apart into A plus B, that's decomposition. Alright, anyone have any questions about that idea? With the idea of either combination or decomposition? Alright, let's look at leavening agents. So talking about baking soda and baking powder. Who wants to read first?
Me.
Alright,
I don't know where we
too late. We're on page 53.
I don't know where we
I got it.
I got it.
Alright.
A
Yes.
substance that causes dough to rise is known as a leavening agent. The most familiar leavening agent is probably yeast, a type of fungus that ferments sugar to produce carbon dioxide and alcohol. The alcohol evaporates during baking and the bubbles of carbon dioxide expand the dough and make it rise.
Good job. Alright, next paragraph. Chris.
So wait, you're ingesting bacteria when you drink alcohol.
What?
You're ingesting bacteria when you
Yeast
drink
No.
alcohol.
Okay, yeast is a living fungus that you put in bread dough. Whenever it reacts, it makes alcohol, like actual alcohol, but it evaporates to where the alcohol is not there anymore whenever you eat the bread.
Nice.
So, yeast makes alcohol, but your alcohol should not have yeast in it. Someone's probably trying to kill you if they're doing that.
What do you mean? How do you try to do it?
Okay, well, because alcohol should not have yeast in it. So if they're taking yeast and dumping it in the alcohol you're drinking, first of all, yeast is gross and nasty. Have you ever tried pure yeast before? It's gross. So it's not. So they're
Like Pop
either.
Rocks.
No, it's not. It tastes like nasty baking soda, basically. It's gross. It has a
I love
weird
bacon.
it has a weird consistency and it tastes like really bitter. It tastes like dirt.
Wait,
basically.
what does it look like again?
What?
What does it look like again?
What does it look like again?
Yeah,
It's like sand. It looks like sand.
Yeah, it looks like coarse sand, basically.
Nice.
Okay, there's different types of yeast, but that's the
Maybe
dry
it's
one.
Wait,
Okay.
how does alcohol make you drunk by, like, because technically when you drink alcohol, do you get high because, or not high, do you get drunk because it's like kind of poison?
You get wasted. But it's the idea.
Wasted.
It's the idea of alcohol. It basically lowers your motor skills and your self-control. But it also affects like your body's ability to keep functioning. So that's how come if you drink too much too quickly, you can actually go into a coma and then die. You basically
You
turn
shouldn't
off
drink
your
an
body.
excessive amount.
That's why people
Unless
do
you're like
like.
a lightweight.
That's why people that do like the drinking
What's that
games
for?
in college, that's how come they'll actually get sick and die, because they're basically daring each other to drink too quickly, and that's why you,
Like the
first of
Florida
all,
parties.
don't want to do that, and second of all, if you decide that it's okay to drink because you're an adult and you're over 21, which neither one of you right now, side note.
I don't drink.
I'm just saying right now, that once you get older
What do
and
you
you
mean?
decide that, then make sure that you don't drink too much at once, because it will kill you. But again, biblically, don't drink. It's better for your body overall, just not drink at all. Alright, continue on.
A number of chemical compounds may also be used as leavening agents. One such substance is sodium bicarbonate, commonly called baking soda. When it is heated, as during baking, baking soda thermally decomposes to produce gaseous CO2, which forms bubbles in the batter and makes it rise.
And it gives you the reaction, you don't have to know the reaction. Alright, back over to Ethan. You don't have to know like the reaction, like know how to do it. Yep.
Another leavening agent is baking powder. Baking powder is a mixture of baking soda, a solid substance that forms an acidic solution in water, and a substance such as cornstarch to keep the mixture dry. Sodium bicarbonate readily reacts with acids to form CO2 gas even without being heated. As long as the baking powder is kept dry, no reaction occurs. But when water is added to it, CO2 is produced, which causes the dough or batter to rise. Calcium dihydrogen phosphate, CaHPO2, is often used as the acidic ingredient. The reaction of baking powder when it is heated may be given as follows.
And then it gives a whole other thing, you don't have to know that. Alright, very last sentence, Chris.
Batter dough is Mexican leavening agent such as rises little when making these used for making unleavened bread.
Alright, why don't you begin a little bit slower so
Brrrah.
Ethan and Jamie can understand you.
Batter or dough that does not contain a leavening agent such as these rises little when baked and is used for making unleavened bread.
Good job. Does anyone know what we typically use unleavened bread for in the United States? Now, different
Wheat.
cultures use it for different things. Not necessarily wheat.
Flatbreads.
Okay, that has a little bit of leavening in it, if I remember
Cookies.
correctly. There's something in particular that you use unleavened bread
White bread.
particularly for.
White bread.
Nope,
Dogs.
It has,
Wheat bread.
alright, nope, it has
Dogs
leavening
and
in it,
white.
like it's fluffy. So what's something, like, what is unleavened bread, unleavened bread specifically? It has,
It's nasty.
fluffy.
What does it taste like?
A very dense cracker. You've probably eaten this before.
Hard cap.
No, that's like, alright, so if you've ever participated in communion or the Lord's Supper, you might
Saltines!
Yeah, okay, yeah. So saltines, or
Crackers,
sometimes they use
salty
other
crackers.
types of crackers
Saltine
for it.
crackers.
But yeah, but it's the idea. The idea of using unleavened bread. Does anyone know why traditionally we use unleavened bread? Besides the fact that Jesus used it in the Lord's Supper, but like,
Because we
what is
don't
that?
got bread anymore.
No. All right. So does anyone know like what does yeast stand for? Represent in Old Testament times?
Fullness.
Okay, it is
Sickness.
Closer.
Disease.
Closer.
Death.
Famine.
Not quite.
Famine.
Nope.
Sadness.
Nope.
Depression.
Nope.
Retardation.
It represents sin. That's how come for the Passover
What?
for the Jews, they were supposed
We
to
eat our
unleavened-
sin?
No, it was supposed to represent for the Jews that they were supposed to eat unleavened bread or bread that doesn't have yeast or sin in it. It was to help them to remember with the Passover how they got passed over in Egypt with the sacrificing of the firstborn. So it's to help them remember that. So for the Lord's Supper, Jesus' Last Supper, it was during Passover week. So that's how come he represented of this is my body that is holy. It doesn't have leaven or yeast in it. So this is my body that is sacrificed for everyone. And then this is my blood with the grape juice today, or wine when we think about it, is the terms for the Old Testament times and New Juice time. This represents my blood that is shed for everyone. So that's the reason why we do this with
Can you
communion.
imagine if there's like a food reviewer back then and they're like, taste of dirty thoughts?
Alright, ready to keep
Sin.
going. Ready to keep going.
Sin.
Alright, well yeah, that's where it comes from. Alright, you wanna have any questions though about the leavening agents?
9.
Alright,
9.
last two types of chemical reaction. Single displacement reaction. These are called single
thought there was
displacement
only
or wait, what?
I thought there was only 3.
There's 4.
I thought you said 3.
Look, there's 4 basic ones. Technically, there's a 5th one as well. But, so the first two, on those 2 pages, this one is a single displacement reaction. It's also known as a substitution reaction or a displacement reaction. What's happening with this one is you have one substance take the spot of another substance. So, your book describes it as you have sodium, it'll react with water, and it'll produce hydrogen gas and sodium OH. Now, how would you name this? As a side note, because you should be able to know how to name these by this point. All right, raise your hand, raise your hand, raise your hand.
Sodium hydroxide.
Good job, sodium hydroxide for it. So, this would be what, Chris, so you don't feel left out. I know, I don't have anything else. That's all I got right now. That's all I got. Yes, water. So, you have first substance, it's good, it's new break. First substance combined with second substance, but instead of doing it like that, they do it as it's A with BC to help show that there's a hydrogen and an oxygen side. The poor B gets kicked off by itself, and substance A takes its spot. So whenever you write it like this, it's a little bit easier to see how sodium goes, I want to get rid of my electrons. Hydrogen, be gone, basically.
Be
And so
gone.
it throws itself on it, and it kicks off hydrogen. This is what's happening in that picture whenever you're asking me about sodium and what happens with what we're mixing with water. Your book has a picture of it, and that's the reason why it wants to react so quickly with it, because it wants to get rid of its electron. Your book describes this, the best way to kind of think of this as well is sometimes you see this with couples, where you have a couple, and then someone comes in and steals the boyfriend or the girlfriend, and the other person is left by themselves, single and alone. So it's a single displacement reaction. So hopefully that has not happened to anyone in the room or anyone in the video, but it's something to where, okay, that's sometimes the best way to think of it. Alright, so keep your focus. So this is whenever you have a substance, it takes the spot of the second one, and so it kicks off to where there's now only, and it has now lost its partner. Alright, so that is a single displacement. I hope you're not doing that in your classroom because it's very
I'm trying to get tired.
Alright, so your book gives off that one as an example. You also see the various metals. We're going to talk about this later on. That metals will also do this as well because metals want to lose their electrons. So your book points out another one with copper, with AgNO3. Copper will take its spot and kick off the silver. NO3. Alright, as a side note, so this one's copper. I'm making sure I copied it down correctly. Alright, AgNO3. You should be able to name that one too. Alright.
Argon oxide.
Me, I know it.
No, okay.
Oh,
So, silver.
Sulfur?
Silver.
I thought say.
I heard-
Silver. Dioxide.
Remember, it's
silver.
an ion.
Silver carbonate.
It's an ion.
Silver.
Rubber guess.
NO is an ion.
NO with lots of O's.
Silver nitrate.
Nitrate. So silver nitrate.
I have
So it
seven.
kicks off silver by itself and it leaves CuNO3. Wait, what or something? Did I? I
Copper
did.
nitrate.
You. Alright. How would you name this?
Copper nitrate.
Ooh, is there more than one version of copper?
Copper 1 nitrate.
Is it?
Then
Alright,
Copper 2
so,
nitrate.
oh, wait, alright, so over here, yeah, it is copper 2 nitrate. Alright, anyone have any questions though about, first off, how to name them? Because remember, test is coming up potentially Wednesday. Alright, but you can see how you have copper, it is taken, silver spot, kicked off core lonely silver, kicked off core on core lonely silver, and copper is now the partner. Does anyone have any questions about that? Your book gives you another example of chlorine and bromine. Does anyone have any questions about the idea of single displacement? Because you have one taking its spot and kicking off the other one.
you clapped your hands and it looked like a dust cloud.
Yeah, I have chalk on my fingers now, so because I've been writing too much, so now it's coming off. Anyone have any questions about this? Alright. Last one. Double displacement. Double displacement if we call it the first one single displacement and only one of them was being traded, what's probably happening in double displacement? Chris?
Double distribution.
Yeah, so both of them are swapping. So NaSO4, CO2. Oh, I'm gonna run out of room again. Okay. Oh, you're not. Okay. So, I just. I knew I left off something. Alright. How would you name this? As a side note.
I got it.
Okay.
Sodium 2 nitrate. Nitrite. No, sulfate.
Alright, so do we use the prefixes with the
Sodium sulfate.
Sodium sulfate. Alright,
What is
a little bit harder.
I got it.
Barium chloride.
Good job. So remember, you don't use prefixes for it. So you just say just the names. Alright?
What?
You get an easy one, Ethan.
That's not easy. I'm gonna say NU.
And what is that?
It's CL. It's got smoosh.
What is it in you?
In A, sorry.
I thought to say.
I ran out of room. I got smoosh.
Sodium chloride.
Good job. And you can have this one because that was hard. It was easy.
Yeah.
Alright.
Barium sulfate.
Alright, so what's happening in this one? So, your book points out that you have basically 4 substances for it. Why are you looking at the You can't see.
We're staring deep down these things.
Alright, so you have substance A, substance B with the anion. Basically you divide them up into the ions. So this is substance C, substance D, because these are the parts for it. So you have a cation, an anion, another
What's
cation, another anion. Remember, what's a cation?
A cation.
I'm not pointing at you.
Positively charged.
Positive charge, what's an anion?
Anion is a negatively charged ion.
Good job. So, to match them up over here, you have, this is A, noticing this one's A again. Chlorine over here is D. I'm gonna not trade my colors. Over here, barium is C, and the sulfate is B for this one. So you'll notice that over here it was A and B together, it's A and D now, and over here C and D split together, so it's C and B. You will notice that both of them traded partners. You occasionally notice this, where if you have one boyfriend-girlfriend couple and another boyfriend-girlfriend couple, and they decide that they no longer like each other, and they swap to where you have 2 whole new couples from it. So, occasionally, now again, our school is so small, typically you don't see this a whole lot in our school because it's so small right
It used
now,
to
it would
happen.
create drama. But occasionally in a larger school you see it. Alright, quick question?
There's a technical term for that. It's called swinging.
What?
It's called swinging.
What is?
That looks
Sounds
nice.
like
Are you sure? Is it an appropriate term? Or does it mean something inappropriate?
I saw it on a commercial on TV, so it has to be appropriate.
Okay. But yeah, so occasionally now again, you want to be careful and not just have a girlfriend or a boyfriend just to have a girlfriend. Well, you're both gentlemen, so you're gonna have girlfriends. But it's the okay.
You're funny. You're funny.
All right, Chris. Make sure
sure you're being appropriate, because remember, at Grace Christian School, we don't joke about such things.
What I do?
Okay, just making sure. Oh, I see what you were getting at. I thought you were going in a different direction for this. Alright, so I see what you mean now. I take back my comment. Okay, so I'll tell you later off video what I thought you
I know
meant.
it.
Okay, I'll tell you later. Alright, so just keep in mind that whenever you have them exchange partners, that this is whenever you have it go from one cation ion, it chooses a different anion. Now remember, you can't have positive and positive together. So you're not going to have A and C together for this because they're both cations. They both want to give up their electrons, so they won't be together. Same idea with the anions. They both want to take electrons, so you can't have B and D together because they both want to take them, and so they can't take them from each other. So that's called, it has to be A and B, C and D. It has to be A, D, C, B. And again, alright, you okay?
And eight.
That's realistic.
Like I said, I take it my comment because I realized what you meant earlier. But now we all understand, so now we're all clear about it. Alright, so anyone have any questions about the double displacement reaction with the idea over how it works where you have the partners are swapping? Alright, anyone have any questions about that? Alright, moving on now. Alright, Chris, you helped me earlier by copying down these equations for it. So looking back for problem number C,
Can they
hold on
see
a
me?
second. They cannot see you. You're safe. You're so fine. Okay, they can see your hand now. Alright, so let's look over at the example. So classify each of the following reactions as a combination, decomposition, single displacement, or a double displacement. So looking over with the examples, letter A, so you have aluminum combined with iron 3 oxide, and iron gets kicked off by itself, and you have aluminum bonded up with oxide. So what type of reaction is that? Raise your hand if you know. Alright, Chris.
Is it called distribution?
Alright, you have one of them taking the spot and kicking it off, so you have only.
Single displacement.
Single displacement because one of them is being displaced. So that was single displacement. Alright, looking at letter B now. So you have magnesium and nitrogen together, making a whole new substance. What type of reaction is that, Ethan?
Combination.
That's combination. Alright, you have you have chloric acid. It looks like HClO3. Technically, that is a type of acid. So chloric acid with potassium hydroxide, and it forms water and potassium chlorate. This is an acid-base reaction as a side note. But what type of reaction is that? So combination, decomposition, single displacement, double displacement. Alright.
Decomposition.
Alright, there are two substances and they're swapping
Double
partners.
displacement.
But they're two and they're swapping partners. So which type? Single displacement or double displacement? Double, because they're both of them are swapping partners for it. Alright, letter E. You have iron oxide. It combines with hydrogen gas to form water and pour iron by itself. So what type of reaction is that?
Single.
Single what?
Displacement.
Alright, anyone have any questions about how to do this? Because that's what part of your homework is going to be over. Part. Because remember, you have the sheet if you didn't finish it yet. And then you have part of this for your homework. Alright, let's practice. So if you look at the section review way at the bottom of page 55, you'll notice it says to classify the reactions in part 1. You're gonna skip it right now. So part 2 is what Chris was helping me Chris was helping me with earlier. I'm blurring my words together.
Christmas?
I think I did by accident. I'm sorry. Alright, Chris was.
That was like Santa boy.
Alright, so what is this first one then? What type of reaction is it? Chris. Composition, combination, decomposition.
Combination.
This one is combination. Good job. What? Because you have two substances. Got that moving my shot. You have two substances. So substance A. Make sure I'm still in the shot. Yeah, I am. A plus B equals AB. They're coming together. So this is combination. I'm just gonna write C off to the side so we won't forget. Alright, what would this one be then? Alright, Ethan.
Single displacement. Hold on.
You have one substance over here,
And you.
and it's breaking apart into two substances over here. So I'm gonna help you out a little bit.
Decomposition.
This is decomposition. So I'm gonna write D off the side so I won't forget. Alright, so what substance is this one? So you have one substance, it combines, and it's kicking it off by itself.
Nice.
Oops.
Single displacement.
That is single bit. So you don't have to write the letters above it. I only did it because it makes it a little bit easier to see. So in your homework, if you want to write above it, that's fine. You
I'm
don't
going to.
have to, but it definitely helps out for it. Alright, this last one, I'll go ahead and I'll copy this one so that way you can go ahead and talk about that last one. Then, yeah, I get to keep going. Alright, so for this last one, you okay with everything?
I think we'd still be if I didn't write that up there, I think we haven't gotten to it yet.
Yeah, it definitely takes a lot longer to like rework them out and resolve them for it, but yeah, I definitely appreciate it. So this one is chlorine plus N. Works my guess. You okay with it?
Write that little.
Alright, so this is the reaction as it starts off. Now, is this balanced?
No.
As written. Why? You are
Iodine doesn't can't
Yeah,
exist
got-
by itself.
good up.
And chlorine.
And chlorine can exist by itself. Alright, so is it balanced now?
Wait, what about sodium?
It's not.
Can sodium exist by itself?
Yes.
Is it by itself?
No. Alright,
Silence.
Alright, so how do I fix this?
Oh, right.
Well,
Okay, wait. We'll let you do one because you did the last one. Alright.
There's 2 chlorine, so there's. Wait, is that chlorine? Is that.
This is chlorine, this is iodine.
Then where's the other chlorine?
Oh, sorry, chlorine. I accidentally left one out. Sorry.
Did that get to 2 too?
Right there?
The chlorine. There.
Like that?
Alright.
Like that? Or should I put the 2 down here?
Yeah, cause, yeah.
Ooh. Should
Yeah, the
I?
chlorine is 2. Oh, it's not by itself. So never mind!
Okay, do I ever get
Right
it by
there.
itself and that's 2?
Yep, right there. That's good.
Okay, so right, this is balanced right
So
here.
Chris gets.
one more set.
Okay.
Just let him finish it. There's only one more set.
Oh, okay. There's a 2 in front of Na2.
Okay, so now it's balanced. Alright, so I have one substance over here, so we'll just say this is substance A. So, B, C, C, and we say
No.
this is B, A. So what type of reaction is this one? Alright,
Single displacement.
good job, it is. It gave you a second single displacement just to check to make sure that you understood which one is what. Alright, anyone have any questions though about how to tell which one is which? Because your homework is going to be over this. On the side note,
You gotta give someone.
not yet, I still have like 5 minutes. Alright,
7
so
minutes.
keep in mind though that you're going to have a quiz over this probably Monday, but it should be really easy because you're literally just matching to say which one is which. So make sure that your practicing is to give you another kind of easier quiz because it knows that sometimes balancing is hard for people. So it gives you a balancing quiz tomorrow, and then on Monday it's going to give you, hey, what type is which? So make sure that you understand which one is which because I don't want you to have a quiz that hurts your grades instead of helps it.
2 more.
Okay.
Is that one considered hard, the balancing one?
It
Is it like a
depends.
50-50 really? Like some students do really well, some don't.
It just depends because it's something to where you have to
It's like
practice and just have a
50-50 here.
skill for it. I give partial credit, so it's not like you're doomed if you get it wrong. I'm not gonna take away all the points. So it's one of those. Okay, you got close, but I believe it gives you a bunch. It's over half of it. It's just straightforward balancing. So it just gives you here's a problem, balance them.
Have you ever had a student get a 0 on anything?
Yes.
Because I heard that Andrew Farnsworth had.
We're not talking
Had a
about it.
negative
We're not
3.
we're not talking about
Or
it.
negative
Video
3.
is being
Yeah.
recorded,
Excuse me?
and we're not going to talk about previous students. We're not
Okay.
How do you get a negative 3?
Yeah. Alright, so thinking back over, as a side note, okay, so we have to cover a little bit of terms and definitions for tomorrow. I'll teach for about 3 more minutes and then we'll review because I want to make sure we review for the quiz for tomorrow. There's not a lot of terms and definitions, but there's a little bit of some. Alright, so look in your text on page number 56. Quantitative relationship from balanced equations. So your book gives you one, just giving you a very straightforward one with hydrogen and nitrogen. Oh, I need to remember to shift back over.
Drop some.
Should have raised your hand, Ethan.
No.
I'm calling you. Alright, so I have hydrogen plus nitrogen yields NH3. What is this? As a side note.
NH3.
NH3.
Nitrogen. No. Hydroxide? Peroxide?
Oh, well, I guess technically since this one is not existing in its cation form, if this one acted like a cation, it would be ammonia, but this one is acting as a neutral substance in this particular
I got
version.
it.
So I guess, so this one it would be nitrogen trihydrogen, ammonia.
No, it wouldn't be hydrogen. It's hydrogen. You have to put the IDE on it.
Well, I guess for this one it's acting like a neutral substance though, so it's more of a binary molecule. It's weird. Yeah, no, this one, let's probably no.
Nitrogen hydrogen.
They still call it ammonia, so it's still acting like it's ion, it's just ignoring the fact that it's an ion at this point. Okay, but as a side note, is this balanced hydrogen? Alright, there's a couple of problems with it. What's the problem with it?
Put 3 in front of the H.
So just put a 3 here? That's it?
No, just put a 3 there first. And first off, hydrogen actually can't exist by itself.
Good job.
So that's 2. So now take the 3 off. What is N? Nitrogen?
Nitrogen.
It can't exist by itself. Can't, right? Alright. And nitrogen can exist by itself, and that's not necessary. Put a 3 in front of the H. And put a 2 in front of the next one. No. That, yeah.
Okay. You got it? Yep, we're done. Okay, so this one, alright, at the side note as well, what type of reaction is this? Combination, decomposition, single displacement, double displacement?
Combination.
Good job. If you didn't come together, everything done. So, your book starts pointing out that, okay, now, can I actually go get 3 molecules of dihydrogen, 1 molecule of dinitrogen, and combine them together to get 2 molecules of ammonia? Can I physically do that in a lab?
No.
No, you cannot, but technically, I mean, theoretically you could.
You could, but could I actually do that if I decided I wanted to make ammonia?
No, you cannot.
I could not.
The
Now,
way to make ammonia is just put bleach and
And drink it.
and whatever it is.
Right? You drink it. Can you drink it?
okay, you're thinking of mixing bleach and ammonia,
Yeah.
but I want to make
Doesn't that
ammonia.
kill you?
Yeah, it's toxic.
Ammonia? Does it get ammonia good?
Something like that.
Not ammonia wise. I mean, if you drink pretty much anything, you just drink a bunch of it, yeah, it'll kill you. But it's one of those to where ammonia.
Water
mixed
kills you
together.
if you drink too much.
Yeah, it can actually. Alright, so for this one, well, we gotta go. So for this substance, if the scientist wants to make ammonia, that he can't say, okay, I'm gonna have 3 individual little molecules of dihydrogen, 1 molecule, 2, well, dihydrogen technically, and then I'm gonna get 2 molecules of ammonia. I have to be able to work with this in a lab. So they basically raise the whole amount so that they can actually physically work with it. Now they can't change the ratio of 3 to 1 to 2, but you can basically increase that amount.
Doubling everything.
Yeah, so basically doubling everything. But instead of just doubling it, because again, I can't work with 6 individual little molecules. I have to be able to actually
Times
be
it
able
by
to see
1,000.
it. What?
Times by like 1,000.
Okay, now remember, what's the,
100.
what's the number that relates basically to say, okay, instead of saying I can work with 1 AMU, I'm gonna work with this in grams. So what's that number that relates? Thank you.
100.
But what's that number? I should wait for the last question, then we'll stop.
Wait, is it 100?
It's a number, it's a special number.
6.022.
Alright, what's that number called?
Andros.
Andros number?
Close, Avogadro's number. So just make a note that you're thinking back
They're
over.
all
Alright,
Italian, man.
what?
They're all Italian. Yeah.
Alright, well just make sure that this is a different sign, you don't get some wrong answers. Alright, your homework for tonight. Finish this sheet, if you don't finish it, so 9 and 10 should be the last one, if you've already finished it. Good job, but just make sure you're ready, because balancing quiz is tomorrow, so make sure you understand it. And if you have questions and need help, either email me or come find me about it. We're also going to do on page 55, application number 1 now, where it says to identify what type of substance is which. So, if you have the answers written down for application number 1, you can see how to balance them, but you don't have to rebalance them if you didn't have the answers written down. You can tell by looking what it's supposed to be, so don't stress out thinking I have to rebalance them, you don't have to. So, that's
rebalance
really,
them?
what?
Don't rebalance them?
You don't have to balance them, you can tell by looking what type of reaction they're supposed to be for it. That's basically your only homework. We're kind of probably finish up, or you're really close to finishing up all of your material either tomorrow or Monday. Alright, thinking back over it.
If we do it tomorrow, does that mean we're gonna have a review on Monday like Tuesday?
Well,
we just
potentially,
gonna
it depends how long it takes to review basically with balancing, because it just depends how fast y'all
I'm
are.
gonna go over everything.
Yeah, but it's everything in this chapter and the previous chapter. So I gotta go over all the math.
We only have 1 chapter of test.
Well, for this one, there's 2. It's chapters 3 and
And
chapter
there's
4.
nothing before that? There's no like, cause I know most tests have reviews from the previous section.
No?
Most tests have like the tiny parts of their sections before that.
You're thinking about the exam.
Yeah, the
exam
exam.
is cumulative. It can't, remember when we had
The exam
test
is
2 in our
the-
class?
So
Yeah,
wait,
it's
why
not there
in
yet.
history did we go over chapters 1, 2, 4?
Okay, for test, we went chapters 4 through 6. So 4 through 6, that was the last test. Now, for the next test,
Yeah.
now we're not gonna have. Okay, so just take it out, study, we'll go over the terms tomorrow, but study your terms from this section with your reactions. So reactions, what the arrows mean, products,